Hi Bobcats! In this video we're going to take a look at writing both the name and the formula for monatomic ions. Monatomic ions mean a charged particle or an ion that consists of a single ion, a single atom. And when we write the formulas for ions, the formula always includes the charge of the ion. Our objectives include to classify an element as forming a fixed charge or variable charge ion, because we're going to write their names a little bit differently, so we need to know which is which first. And then to predict what the charges are on the fixed charge ions, and then to write names and formulas for both. This version of the periodic table is showing us which elements form fixed charge ions. These are elements that every time they form an ion, that ion always has the same charge. So the elements that are in purple are fixed charge. When they form an ion, it always has that same number. All of the unshaded elements form variable charge ions. And so that means that depending on the reaction conditions, they might form an ion, say, with a +2 charge, or in other cases, and they might form a +3. It just kind of depends. Notice that pretty much the vast majority of the periodic table forms variable charge ions, and there is one group that will not form ions, and those are the noble gases. So over here, this last column, they do not form ions. We also are going to kind of gloss over the metalloids. So anything that we're saying about the charges will just apply to the metals or the nonmetals. So the nonmetals include all of the elements that are to the right of that gray diagonal stair step. And when I cropped this image to put in here, I apparently picked up aluminum, which is shaded purple. Aluminum is not part of the slide because it's a metal. So all the discussion we're having here applies to the nonmetals. And I also want to just go ahead and take hydrogen out of this. Hydrogen rarely behaves like the rest of the halogens, but every once in a while it does. Okay, so there's a really simple pattern here to the charges that the nonmetals form. The noble gases won't form any charge, so we're going to start numbering the noble gas column with a 0. The halogens will take a -1 charge because they only have to pick up 1 electron to reach a noble gas configuration. The chalcogens pick up 2 electrons, which gives them a -2 charge. The nitrogen family will pick up 3, giving them a -3 charge, and the carbon will pick up 4, giving it a -4 charge. So these charges only apply to the nonmetals in these groups, so only the elements above this zigzag line that I just added in. Okay, when we go to name one of these anions or negative ions, we're going to change the ending of the element's name to IDE. So for instance, when oxygen forms an ion, it forms an ion with a -2 charge, and instead of calling it oxygen, we're going to call it the oxide ion. Now nitrogen, being in group 15, is going to form an ion with a -3 charge, and instead of calling it nitrogen, we're going to change that ending to IDE, and it will form a nitride ion. The fixed charge metals are a very small group of metals. They will be the metals in group number 1, which will go +1, and in group number 2, which will go +2, because when they lose those valence electrons, they are left with that underlying noble gas core arrangement of electrons. In addition to that, there are 4 other elements that are fixed charge metals, and they form kind of a diagonal over here at the intersection of the P block and the D block. Sometimes this is referred to as the diagonal rule. Their charges will be equal to the last digit of their group number. So silver is in group number 11, so it's going to go +1. Zinc and cadmium are in group 12, so they'll go +2. And aluminum is in group 13, so it will go +3. And once again, those charges only apply to the elements that are in purple. When we name one of these fixed charge metal cations, we just name it by the same name as the element. So if we're going to write the ion for sodium, sodium is in group 1, so it'll have a 1+ charge, and we simply call it the sodium ion. With the positive ions, we don't change the name at all. Aluminum is over here in group number 13, and so it'll be a +3, so it'll be Al with a 3+, and we'll call this the aluminum ion. Very good. You'll find that in all of the English-speaking countries except for the United States, aluminum is called aluminium. So we've looked at the fixed charge anions, the nonmetals, and the fixed charge metals. The vast majority of the metals are all of the ones that were unshaded. They were not purple in the last slide, and they are variable charge metals. They can commonly take more than one charge. And what we will do with these variable charge metals is say in the name of the metal what the charge is with a Roman numeral. So for instance, if we have down here on the left an Fe+2 ion, the +2 charge gets written in as a Roman numeral 2 in parentheses following the name iron. But iron also commonly forms a +3 charge, and we will put that into the name with a Roman numeral 3. When we read these, we just simply say the Roman numeral. So for instance, the first one would be read as the iron 2 ion, and the second one would be read as the iron 3 ion. And just in case you're a little rusty on the Roman numerals, 1 is an I, 2 is 2 I's side by side, 3 would be 3 I's, 4 would be an I before a V, 5 would be a V, and 6 would be a VI, and then sometimes we need a 7, but I'm out of room, so I'm going to write 7 up above. 7 is a VII. The way the math works here is I gives us a value of 1, V gives us a value of 5. If we have values of the same level grouped together like I, you add them together. If you have a small value in front of a big value, you subtract. So IV means take 1 away from 5, and that gives you 4. If you have a small number after a big number, then you add them. So VII would be 5 plus 2, or 7. In these two examples, we want to change the symbol for the ion into a name. So what is the name for Ti with 4 positive charges? Well, Ti stands for titanium. And when you look at titanium's position in the periodic table, you'll see that it is indeed a variable charge metal. So we have to put the Roman numeral 4 in parentheses after the word titanium to name this ion. For the next example, what is the name for Ca with 2 positive charges? Well, the element name is calcium. And with two positive charges, you might be tempted to put a Roman numeral 2 following this. But if you look at where calcium is in the periodic table, it is a fixed charge ion. So we don't write the charge with Roman numerals because it's fixed charge. This guy is just calcium ion. And so the difference here is that calcium is a fixed charge metal, whereas titanium is a variable charge metal. Our first objective was to classify an element as forming a fixed charge ion or variable charge ion. Our second was to predict the charges on the fixed charge ions. And our last was to write the names and formulas for both types of ions.